Hey Mustangs, in this video we're going to be taking a look at energy and energy transfer. So this is actually a continuation of the last video that you saw. So we're going to start where we left off, looking at food chains. So in the last video we saw that you could take these organisms here and put them into a food chain to show how energy is being passed along. So you always start with the producer that passes energy to the next organism, and it keeps passing along until you get to your top level consumer here. And then when you look at these, remember each organism represents a trophic level. So here we have 1, 2, 3, 4 trophic levels. And then we can name each level. So we have the producer. All food chains start with the producer. The first consumer called the primary consumer. Then you have the second consumer, we would call the secondary consumer. And then finally our third in this case, and we would call it the tertiary consumer. So we can name each trophic level based on where they lie within the food chain. Producer always coming first, and then primary, secondary, tertiary consumer. Now, food chains are great for studying how energy gets passed along, but out there in nature, you don't see a mouse just eating wheat or a snake just eating mice. All living things out there have different food sources. There are a few exceptions to that. There are organisms out there called specialists, and specialists eat only one type of food. So like pandas are known as specialists, they only eat bamboo. Then you have your koalas, they're specialists, they only eat eucalyptus leaves. Specialists will only eat that type of food. The bad thing about being a specialist, if all the eucalyptus leaves get wiped out, then koalas don't have anything to eat. If bamboo gets wiped out, then pandas don't have anything to eat. So it's not really a good thing to be a specialist. So when you look out there in nature, we see animals have different food sources. They feed on more than just one type of thing. So a snake might feed on mice, rabbits, squirrels, a large number of food sources there. So out there in nature, we usually don't see food chains by themselves. We see it like we see here. We see food webs. So a food web connects all food chains together in an ecosystem. And this is actually a really simplified food web. Out there in nature, you're going to have a lot more complexity. So let's go ahead, see how many food chains are here. So pause the video and count it yourself and see if you can find out how many food chains, and then I'm going to show you right now. So let's go ahead and see. So we have here's one food chain. Here's two food chains. 3, 4, I'm going to switch colors here. 5, 6, 7, 8, 9, and finally 10. So we actually have 10 food chains that are part of this food web right here. So all you do to figure out how many, you just follow the arrows. So you follow them, showing the energy transferring from one organism to the next. All right. So what happens to energy? As we move through a food chain, as we move through food webs, what is happening to energy? So one thing that we want to remember is the law of conservation of energy. So energy can't be created or destroyed, but it can become different forms. It can be converted into different forms, and it can be transferred around. So some examples we see here, cars change chemical energy and gasoline to mechanical energy for movement and heat as well. Plants, like a tree here, are going to change solar energy into chemical energy that we can then use. And if you remember, the chemical energy we're talking about here is usually glucose. That's our main source of energy there. So there's a whole bunch of different ways you can convert energy from one form to another. How much energy gets from one trophic level to the next? So this is a big idea right here. You want to make sure you understand this. If you take a look at the pyramids and you're good at math, you might be able to figure out how much energy gets transferred from one level to the next. So you can look at this pyramid here, or you can look here, and if you're good at math, you kind of see it. It's like, whoa, that's obvious one there. So the amount of energy that gets passed from one level to the next is only 10%. Okay? So 10% of the energy gets passed from one trophic level to the next. So you see here, the primary producer, 10,000 joules. The primary consumer only gets 1,000. Secondary consumers get 100 joules, and then tertiary only 10. So only 10% of the energy available in one level actually makes it to the next level. So you might be wondering, okay, only 10% is getting passed along, what happened to the other 90%? That's a lot missing there. And we just saw you can't create or destroy energy. So that means it must be getting converted. So our big question, where does all the energy go? Most of it is used or converted by organisms for their own body functions. So used for growing, moving, reproducing. So converting it to other forms of energy and using it, can't destroy it, but using it by converting it. And then a large amount, if you look at the pyramid here, a large amount of energy is lost as heat. So you see here in this picture, organisms produce a lot of heat. One good example that shows that you produce heat is the maintenance of our body temperature. The fact that we stay at 98.6, and a lot of that is generated from the chemical reactions that we do in our body, and that allows us to maintain that 98.6 degrees Fahrenheit body temperature. All right, that's it for the notes. Make sure you go down to your summary at the end and write at least 5 sentences or more.